In this video, we're going to look at a Zener diode as a voltage regulator. Now remember, with the Zener diode, it's a little different than a regular diode in the fact that it blocks up to a certain voltage, its breakthrough voltage, and then it maintains that voltage across it, which makes it very ideal for a voltage regulator if you have a load that has to have a constant voltage across it. Now we also have to have a current limiting resistor on this side as well. So you've got your load and your current limiting resistor. Now let's throw some values at this just to walk through how this all works. So in this case, I've got a 24 volt source. I've got a 100 ohm current limiting resistor there. I've got a 500 ohm load, and I've got a Zener that has a breakthrough voltage of 15 volts. Well, with 24 volts on it, this guy is going to block 15 volts and put 15 volts across the 500 ohm resistor, and the remainder of it is going to go across the 100 ohm resistor. So I have 15 volts across my load, and then up with 9 volts across my 100 ohm resistor. Now I've got basically everything I need to figure out currents. I can determine my current by going 15 volts using Ohm's law divided by 500 ohms, and that will give me a current of 30 milliamps. And up here on my current limiting resistor, I can just take 9 volts divided by 100 ohms using Ohm's law, 90 milliamps. And the only thing left to figure out now is I can figure out what my Zener current is. Well, if up here I have 90 milliamps and there's a node here, I have 30 milliamps coming to this node and suddenly it becomes 90. That means that across this Zener, I must have 60 milliamps flowing. And that's it. That's as far as you need to know really for a Zener diode circuit acting as a voltage regulator. As long as you remember that you need to have this Zener has to be in reverse bias. If it was the other way, then you would just see the regular 0.7 volt drop across it. So as long as you have this fella right here in reverse bias to the source, you're good to go.